Today we will be talking about the content of lecture. We will be talking about bits, bytes, and integers. One of the first programs that you in programming is this famous Hello World program, right? You write a couple of lines and it prints you Hello World. But what happens under the hood? I mean, it's like driving a car, but you really don't know what happens like in the processor, what happens in the I/O devices, and so on. So let's look carefully. So this is our, hello.c program. It's pretty simple. The first thing that we have to look at is what happens when we compile this program. This compilation, it's like you may be writing just a single, then we get this modified text source program, which is again a text, hello.i. This modified source program goes through a compiler, and from the compiler then you can get the assembly program, which is another text. Note that when I talk about assembly here, it's assembly language is yet another programming language, and you can actually write code in assembly, and we will see this what those instructions are. And so you can get another program. So this compiler is effectively translating your source program, maybe in C, Python, whatever it is, into an assembly program, another language. There's the assembler, which takes this assembly program and then converts this into an object file, which is binary. So this is no longer text. So you cannot, even if you open it, you will not be do that. And this is called a relocatable object program. In this code, then you go through a linker where C program, there is no code for for the printf. You just included a library, but the code for that library doesn't exist. So what linker does is it takes this object file of your own program, combines it with the printf's object file, and then finally you will get this binary executable, which can then run and get your basically output. So let's look in detail how it actually works. So what does the preprocessor do? So here's our text program, and I'm also writing the code, okay, the instructions to generate. And the preprocessor, what it does is it looks at directives, like when you look at this sharp, which says include stdio. This is a directive for the preprocessor. The preprocessor is not interested in other parts of the code, like this part, okay? So when you have a define, for example, when you have an include or anything starting with a sharp is processed by the preprocessor. And what it does is when you say include stdio.h, there's a header file which has the definitions of the standard input-output functions. So this code is then inserted into your file. So this part is automatically copied from this here. And then the main difference is now, instead of this include stdio, then you have all this detailed descriptions that's included in the stdio.h file. So that's what the preprocessor does. And if you have a define, which then it will be basically, it will go through the text and replaces whatever you have defined with the value that you have basically defined. Then comes the compiler. The compiler takes this preprocessed source code and then generates an assembly language translation, okay? And you can, when you do the compilation step, it usually, everything is wrapped up into one single, basically command, but you can actually see how it actually works by using these flags here. So it says that the -s indicates that you want to see the assembly code that's generated by your compiler. So when you look at this code, this is again a text that you can read, and there are a lot of there are a lot of things, like for example, this is the read-only data section, and here's something information about the hello.c, and maybe there are some global main variables. Then here we have main, and in our main function, what you see here is you can see the translated code of our hello.world. You can see like instructions like push L EBP, move L ESP, etc. Okay, add, call, leave, return, etc. etc. Yet this is still, so you can actually write your own assembly code, and you will be writing your own assembly code like this. But this is still not executable, because what this does, this is again yet another text file. Now take that assembly source code and then pass it through the assembler. Now what the assembler does is it translates this into a binary basically object code, no longer readable in human form. So when you basically open this up, for example, using OD, which is octal dump, okay, you can look into the contents of this object file. You will see that there are a lot of cryptic things that you cannot read. This translation from this assembler into object code, and this one also back to its assembly code, it's doable by like a GNU debugger and etc. And you'll be your first assignment will actually be about this. So now what you get is this object file, which is in machine language. This is the binary code that can be executed. But this object code is not complete yet. It's not complete yet because your hello.o doesn't include the code to be executed for the printf function. So you just say that make a call to the printf function, but where is that printf implement and compile? And actually, in your library, the printf code, and there is a code for this, and this is actually again compiled, and object code, a binary code for printf is actually available in your system, your file system. And what the linker does is, what the linker does is it merges these two object files, and then it will get you an executable program binary. Now this one has the code for everything. Okay, so it includes the printf code, it includes your hello world, and etc. And when you look at, for example, the contents of this hello executable, then you will see that it's in here. After this, of course, you get your hello world, and that's it. Now, what happens in the hardware? In the hardware, well, I mean, you have a main board, but what we have is it has we have a central processing unit, which we call CPU. Then we have like two bridges, and let's just move on to the next one because it becomes much easier. So this is the overall picture of a typical computer system. So here we have our CPU. Now the CPU does the computation, but what it doesn't do is it doesn't it needs to communicate with the other devices, like other devices meaning first merged, main memory. It needs to read and write from the main memory, and plus it needs to connect with other I/O devices through the I/O bus. Okay, these include your mouse, keyboard, display, disk, anything that you like, your camera, your microphone, whatever it is. Okay, and the CPU, then we have this I/O bridge, which basically, when you try to read, when the CPU tries to get some information, read or write from memory or these devices, there's this bridge which splits the request into two. There's the memory bus, and then there's the I/O bus. The difference is, as we will see later, the memory bus is a fast one, okay, because the main memory, in some sense, it's yet another I/O device with which the CPU interacts, but it's a very special one, and hence the memory bus is fast. Whereas the I/O bus, this is slower, and the reason it is slower is you want to make sure that when you plug in different devices like your, for example, mouse, keyboard, display, it has to support all of them. Okay, and it has to be cheap, so that this is why there's this I/O bridge which splits the requests based on this. When we are reading the hello command from the keyboard, effectively you're sending data from this bus to the register file. You read character by character, you put them into your registers, okay, and after putting them into register, you actually also write them in your main memory. After this, what happens is like, the PC then, once it confines this, then it sends this information to the disk, and from the disk, then you read the hello executable, and this executable that is then written into your main memory. CPU then goes ahead and fetches them instructions one by one, puts and then executes them onto these register files. And in the meantime, during execution, then it will be going through the graphics adapter and displays that hello world message.